Welcome to our lesson on Ohm's law and power. First we'll introduce Ohm's law, and then we'll talk about the power associated with electrical circuits. A fundamental concept that relates electron flow or current flow to potential difference and resistance is known as Ohm's law. As electrons move through a circuit, they encounter resistance in both the conducting wires, where the resistance is negligible, and more importantly in various devices or appliances that may be placed in the circuit. These are often referred to as resistors. Some appliances or resistors only convert electrical energy to heat, but others are designed to convert electrical energy to sound, motion, or even light. The flow of current in a circuit is influenced by two factors. The first factor is the voltage or potential difference of the circuit. This is a measure of the energy that electrons carry through the circuit. The second factor that influences current is the resistance of the conductors. Resistance is affected by four main factors. The first factor is resistivity. This is due to the atomic or molecular structure of the conducting metal. Some metals are better conductors because they have a looser grip on electrons. Another factor is the cross-sectional area of the conducting wire. Just as water flows through a large pipe easier than a narrow pipe, a thick wire will be a better conductor than a thin wire. The conductor length also affects resistance. Resistance varies directly with the length of a conductor because a longer path means a longer fight to move across that resistor. Finally, conductor temperature affects resistance. As a conductor heats up, its resistance increases due to the increased kinetic molecular motion of particles inside the conductor. If you combine all the ideal properties of a good conductor, you would require a durable and flexible metal that has a low resistivity. Copper, gold, platinum, silver, aluminum, and even mercury in some thermostats are good candidates, although cost may rule out some of these metals. Three other properties are that the conductor be short, thick, that is, have a large cross-sectional area, and it should also be a cool conductor. If the conductor heats up, the resistivity increases. In 1826, George Ohm discovered that current and potential difference were directly related. That is, the current I is directly related to the potential difference. If the potential difference increases, so does the current. He also discovered that current was inversely related to the resistance. That is, as the resistance increases, the current will decrease. And making this an equality by choosing a proper unit for both current, potential difference, and resistance, we get I is equal to V over R, or another name for this is, of course, Ohm's law. Ohm's law is often written as V is equal to IR. You should remember that Ohm's law applies to most basic circuits. In more complex circuits, and even in some light bulbs, resistance can be affected by voltage, and so Ohm's law may not always apply. But for this course, assume that all circuits are basic, therefore they do obey Ohm's law. As a circuit carries energy and charge, it releases the energy over the time, and this is the definition of power. Power is equal to work over time, or in other words, a change in energy over time. Since potential difference is equal to a change in energy over Q, we can show by substitution, first of all, that the change in energy is equal to voltage times charge. And so, substituting for power is equal to change in energy over time, we put power is equal to voltage times charge over time. You'll notice here that we have charge divided by time. Earlier we discussed that charge divided by time was equal to current. Current is the rate of flow of charge. And therefore we can see that charge over time is equal to current, so power is equal to V times I. This simple derivation shows that for a circuit, power is equal to V times I, or in other words, the potential difference times the current. If we combine the power of a circuit, P is equal to VI, with Ohm's law, which of course is V is equal to IR, by substitution, if we substitute V into the power of a circuit, we get P is equal to I squared R. Again, if we take P is equal to VI and solve Ohm's law, or manipulate Ohm's law for I is equal to V over R, by substitution again, we get power is equal to V squared over R. In summary, the formula for current, I is equal to charge divided by time, Q over T. Ohm's law, V is equal to IR. And the power of a circuit can be determined using any of these three combinations. Power is equal to VI is equal to I squared R is equal to V squared over R. At this point, you should review a number of problems and applications requiring these new equations to find solutions.